Hello and welcome to your geometry lesson for today. Today we're going to be lesson 1-3 and your learning target is I will be able to use the midpoint formula to find the midpoint on a segment, and I will be able to find the distance from one point to another. All right, what is midpoint? Midpoint is a point that divides a segment into two congruent segments. So like we talked about in a previous lesson, A, M, and B are all collinear points, and M, according to geometry terms, is between A and B because they're all collinear and they're between points A and B. Now this, according to the tick marks in here, shows us that AM is congruent to MB, making M the midpoint of AB. Bisect. What does bisect mean? Well, I think most of you are going to say the same thing that this diagram is, and it is going to cut something in half. So, a segment bisector. It's a geometric figure, whether it's a point, a line, a ray, a segment, a plane, something that intersects a segment at its midpoint. So if you look here, we've got M is between A and B, and M is the midpoint, and then you can see the line coming through DC. That line could be considered a segment bisector. So line CD is a segment bisector of AB. And the big thing that we need you to understand here is that AM is going to be equal to MB. In yesterday's lesson, we set up the segment addition postulate. So we said AM plus MB equals AB. Now that is still true, but sometimes they don't necessarily give you enough information to figure things out. Like they could give you the length of AM is 2x plus 5, and they could say that MB is 3x plus 15. Well, if you don't know what AB is, you cannot set these up to be equal something. You can't say plus and then equals what? We don't know, so we can't fill this in. We can't call it x. So what would we do to solve this? Well, we can still find out what x is, because according to this diagram, M is that midpoint, or we have a segment bisector. So we know that AM, that 2x plus 5, would be equal to 3x plus 15. So it's not that this isn't true segment addition, it's just that sometimes it doesn't help us to solve the problem. All right, now can we draw line T bisecting segment MN at point H? So it looks like we're going to have a segment here, and the two endpoints of this segment are M and N. Notice I'm using capital letters to name those points, and it's saying line T is a bisecting, so line T is a bisecting segment, so I need to have lowercase cursive t at point H. All right, if you think you're done right now, you're not, because how do we know that it is bisecting? Just drawing a line so that it goes going through the middle does not work. So how do we tell somebody else that this is actually the midpoint? So we have to say MH is congruent to HN by putting in those tick marks. So please don't forget to put in the tick marks. So capital letter for points, lowercase cursive t for naming the line, and then point H and your tick marks. All right, M is the midpoint. So if we try to set up here using what we had yesterday, we would set up 4x minus 1 plus 3x plus 3 equals VW, because we don't know what VW is. Now it looks like we have two unknowns in here. We have an x unknown and we have a VW unknown. When you have two unknowns in only one equation, we can't solve that. But what else do we know? We know that M is the midpoint. So don't we know that VM is going to be equal to MW? So can't we set up 4x minus 1 equals 3x plus 3? Now let's go ahead and solve this. I'm going to subtract 3x from both sides, and I'm going to add 1 to both sides, so it looks like x is 4. Now they want to find the length of VM, so I'm going to plug it in here. So we've got 4 times 4 minus 1, so it looks like VM is going to be 15. Well, how long is MW? Well, if we plug a 4 in here and plus 3, MW is also 15. And can you find the length of VW? Well, we can add those together, 15 plus 15, and get 30. All right, identify the segment bisector of PQ. The segment bisector is going to be line L, lowercase cursive. Then find MQ. Let's see, because that's a midpoint, finding Q. Segment addition is not going to work here. So because this is a bisector, we knew that these two segments need to be congruent. So I'm going to add 3, and I'm going to add 2x. So 7x equals 14. And we're going to divide both sides by 7, and x is 2. Are we done? Nope, they want to find MQ and MQ, so I'm going to plug in my 2 here. So 11 minus 2 times 2, so 11 minus 4. So it looks like MQ is 11 minus 4 is going to give us 7. And they don't give us any labels, so we're just going to say 7 units. All right, given here, what do we have? M is between A and B, and it looks like it is the midpoint. So there is a midpoint formula, and if you look, when you add up x1 plus x2, add the two x values, and when you divide by 2, that's basically taking an average of the x's, and you're going to do that again with y. So add them up, divide by 2 is that midpoint formula. And then we also have a distance formula. So you're going to want to write this midpoint formula down and maybe have it set where you can look back at it if you ever need this. And then we're also going to have a distance formula here. And this distance formula here, looks like I got to move my screen a little bit. Oh, that didn't stay. All right, so the distance formula is going to take your two x values and subtract and then square, added to your two y values, subtracting and squaring. So again, you're going to want to write this formula down. So I don't know if you need to pause it, but get this formula written down so you can get at your midpoint formula and your distance formulas. All right, so the endpoints of RS. All right, we have a segment, and it is RS. So we have R is at 1, -3, and S is at 4, 2. Find the coordinates of the midpoint. All right, so they want to know M here being in the middle, and what is this ordered pair going to be? So finding the midpoint of this M, we can use that formula that we just found out. So take the two x values here. So we can take 1 plus 4 and divide by 2. And then we can do the same thing for the y values. So -3 plus 2 divided by 2. So 1 plus 4 is 5 divided by 2. Looks like we're going to have 2.5. And -3 plus 1 is going to be a -1 divided by 2. So we'd have -0.5. So find the coordinates of the midpoint. We're going to add and then go ahead and divide by 2. All right, in another problem here, so I'm going to erase this one so that we can get to the second one here. Now I've got some room to write. All right, the midpoint of JK, so we have J and K, and now they're telling us that this midpoint right here, M, is at 2, 1. One endpoint J is at 1, 4. Find the coordinates of endpoint K. So you can pause the video right now and then go ahead and give this a try, and then I'm just going to continue working this out right now. There's a couple different ways you can do this, but one method is what we call the hop method. And the hop method is we're going to start here at 1. So if I'm at a positive 1, and M goes to a positive 2, and this is right in between, we have to hop the same distance to find out what K is. So if we went from 1 to 2, and this is adding 1, then I need to add 1 here, so I can get this value is going to be K. Now we have to do the same thing. If we're starting at J is at 4, and then it goes to 1, what's happening here is we are subtracting 3. So then we'd have to do the same thing, hop the same way on the other side. So we need to do 1 and subtract 3. So 1 minus 3 is going to give us a negative 2. So K is at 3, comma, negative 2. Now another way of doing this is setting up the formula. So finding the midpoint of x. What we're going to do, the midpoint of x, remember we go x1 plus x2 and divide by 2. Well, in this particular case, we know that the midpoint of x is 2, and we know one of the x values is 1. We do not know the other one. So I'm going to multiply both sides by 2, so we get 4 equals 1 plus x, and then subtract 1, and we get 3 to be equal to x. And that's what we got when we did the hop method. We got this 3. Now you can do the same thing for the y value. We know the midpoint of the y value, so the midpoint of y is going to be y1 plus y2 divided by 2, and we know the midpoint of y. The midpoint of y is 1, and we know one y value is 4. We do not know the other one. So I'm going to multiply both sides by 2. So now I'm going to take 2 equals 4 plus y, and now when we subtract 4 from both sides, we're going to get 2 equals y, and that's what we got up there. So that's called the hop method. All right, here we're going to find the distance between r and t. So remember the distance formula. We're going to take x1 minus x2 quantity squared plus y1 minus y2 quantity squared. So the two x values, so we are going to take 2 minus 4 quantity squared. Remember, 2 minus 4 is going to be negative 2 squared, and negative 2 squared is 4. Now I'm going to go through and do that exact same thing with y. So we're going to take our y minus our y. So we have 3 minus a negative 1 quantity squared. So 3 minus a negative 1 is the same thing as 3 plus 1. So we've got 4 squared, and 4 squared is 16. So we are going to get the square root of 20. Now rounding this square root of 20 here, I don't have my calculator handy. So they're asking us to round this to the nearest tenth. So we have the square root of 20 is going to give us about 4.5. All right, that's the end of it. So you should now have an online assignment, lesson 1-3. So head into your Big Ideas book and work on your homework.